Morning, Mr. Lesham is here, and we are continuing with calculus. This is our third lesson, and today we're going to calculate the derivative using first principles. Now, actually, we've already done it. What we will do different today is I'm going to explain now. So, already last lesson, we looked at a curve, okay, f of x. And what we did is basically calculating the gradient of the slope at a specific point where x is equal a. A can be any number, okay? And we already called it the derivative, okay? So to calculate the derivative at a specific point, I'm emphasizing at a specific point, what we did, we took the f of a plus h. We basically took 2 points, if you remember. We took a point x equal a, and another point a plus h, okay, a little bit to the right, h amount the way to the right, and then we minus f of a. We did the difference between those two, f of a plus h minus f of a. That's the delta y, the change in the y, and then we did the difference between the x's, which is a plus h minus a. We only have h at the bottom. Okay? That's actually not even the gradient, that could be even average gradient. To calculate the gradient at a specific point, what did we have to demand that h is equal to or close to? What is h is? It's very, very, very close to 0. Okay? When we write it like this, limit h approaches 0. We can't put h actually equal to 0 because it's undefined. Okay, and we actually calculate this. We called it the derivative. We put a little line there to show us the derivative.
What is
the gradient at that specific point. Okay, I'll pause for a question. Didn't use the word derivative. I'll use it now. The derivative of a function is the gradient at that specific point. Okay. Now, what we're going to do today, it's actually identically the same. I'll write it in green. Okay. Instead of finding the derivative or the gradient, the point, instead of finding it at a specific point A, I'm going to find the gradient at any point. So x can be anything. Okay? So the derivative is going to be f x plus h. All I'm doing is instead of writing A, which is a specific point, I'm going to put an x, which could be anything. Okay? But the formula is really the same. Okay, just instead of a, I've got now an h. Okay, and again, I'm taking the limit h approaches 0. That's the formula. That's the derivative of f. If I have a function f, this is the derivative of f. Okay, so let's do it for a bunch of questions. I know it's a little bit up in the air what I just said now. So let's look at it in a specific example. I've got a function, x squared plus 1. What kind of function is it? What does the graph look like? It's a parabola, smiley face, yeah? Okay? What I'm asked to find is the derivative of that function. Okay? So the derivative of a function is basically the gradient of that function in different places. It's in itself a function. Okay, now I can start talking here and now I'm just going to confuse you. Let's just calculate it and then see if I can give you some more information what it means. All I've got to do is use this definition, and we've done these things last lesson, so it's not going to be different. Okay, so I'm gonna write down, okay, f prime x is basically in the limit where h approaches 0, and I'm gonna write f of x plus h. But let me first of all write down minus f of x. What is f of x? Well, this is f of x. Yeah. So for this specific case, I'm gonna write f of x is x squared plus 1, but I have to put it in brackets, right?
Yeah.
So that's the easy. Okay, what is f of x plus h? We've done that sort of stuff last lesson.
F of x plus h is...
So I put x of h plus x plus h squared plus 1. Okay? Right, so anywhere I've got, wherever I have x here, now I'm going to sub x plus h. So it's a little bit confusing, but I think you've done that sort of stuff. And I'm dividing it by h. Okay? It's just when somebody asks you to find the derivative, okay, that's the derivative of f. Okay? the derivative of it, you just use this formula. I'm going to try and explain to you what the derivative means maybe when you finish this example. Okay, we start opening, okay? And every time, remember, we write limit of h approaches 0. This is just to remind us that h is a flipping small number, okay? So I'm going to write h, okay? Call up. What should I do here?
So it should be x squared.
X squared plus 2xh or hx, doesn't matter, plus h squared plus 1. Okay? Minus x squared minus 1. That's why it's so important to have the brackets. If I didn't have the brackets, it would be plus 1, but it should be minus 1, which will cancel that one. Okay? Equal limit h approaches 0. Okay, x squared cancel out, 1 cancel out. It's always going to happen. So here at the top, I should only have things with h's on it, okay? So I'm going to have 2hx plus h squared divided by h. Can I put h equals 0? Every time you got to ask, can I not put h equals 0? Not yet. Take a common factor. Okay, so I'm going to have an h, 2x plus h divided by h. In the limit, h approaches 0. What do I do now?
Cross.
Get my red pen. Okay. Equal. In the limit, h approaches 0, 2x plus h. Alright, can I put h equals 0?
Yeah.
I can, I'm safe now. It's out of the denominator. So we get, if h equals 0, what do I get?
2x.
2x. That's it, 2x. Okay, first of all, I want you just to see if you understand why I got 2x, and then we'll try and understand what that means. I think you all understand the mechanics of what I've done, but I don't think you understand. I'll write down the answer here, by the way. I'll write it. So the derivative, what you need to write, the derivative of x is 2x. Okay? Now I'm going to try and explain, what does that mean? What does that mean? I don't think any of you really understand what it means. Okay? What we discovered is that if we have a function which is x squared plus 1, the derivative of that function is a function in itself, which is 2x. Okay? And I'll try and now, by drawing, maybe explain to you why does that make sense. So you guys told me that x squared plus 1 is a smiley face. Oh, that's shocking. Okay? So it's a smiley face that goes through which point? What is that point? 1. Okay? When x is 0, y is 1. Okay? This is f of x. Okay? Now, alright. Let's just think about it for now. Let's go from the left to the right and ask yourself, what's the gradient? Is it positive? Is it negative? Is it increasing? Is it decreasing? Okay? What's the gradient here? The derivative. Well, let's call it derivative. What's the derivative? Gradient. It's negative, isn't it? Okay? The slope, it's a downward slope. And now, as I'm moving towards 0, what happens to the gradient? Is it becoming more negative or less negative? Less negative. Until here, what's the gradient here? 0. No. And then over here, what happens to the gradient now? It becomes positive and it's increasing. Okay, so remember that. If I'm looking at the gradient, it goes from very negative to less negative, 0, very small positive, increasing. Okay, now let's plot in black the derivative that we got is 2x, right? What kind of graph is this going to be? Y equal 2x. First of all, is it a parabola, is it a straight line, exponent, what is it? It's linear, it's a straight line. What's the intercept? Where does it cross the x or y axis? 0, 0, right? It goes through the origin, right? Right? Okay. What is it? The positive gradient or negative gradient?
It's positive.
It's positive. So it's something that looks like this, right? This is something that looks like this. Okay? That's equal to 2x, and that's equal to x squared plus 1. Now, check out what's happening here. If I'm looking at a point here, the gradient we said is negative, isn't it? Yeah, the gradient is negative. This graph shows you the gradient of the blue graph. If the point for negative x is here, the gradient is negative. As I'm moving closer and closer to 0, the gradient is still negative, has become less negative until here the gradient is, what is the gradient?
Because it's in the positive
Zero.
quadrant.
The gradient is 0. We can see that black graph told me, yes, the gradient is 0. And then if I keep on moving to the right, the gradient is positive. Yes, this tells you the gradient is positive. So you see you've got two functions here, or two graphs, the blue graph and the black graph. The black graph, the derivative of f, plots you the gradient. I'll give you a specific point. I'll give you a specific example. Let's say we want to know, x equal minus 1. Okay? Now the gradient should be negative, right? At x equal minus 1, right?
Yes.
Yeah. Okay. What does this tell you? What is the derivative at minus 1? If I put minus 1, this shows you the derivative. It is?
Wait.
If I put x equal minus 1, what is the derivative? Negative 2.
Yeah.
Okay? So this thing tells you, okay, that the derivative here is minus 2. Okay? The derivative of this, not of this. The derivative of this is minus 2. If I check this point, x equals 0. What is the derivative according to this function? 0, which it should, because we said it's 0. If I check x equal 1, what should be the derivative? What does this tell you? It's 2. And it should be positive, right? If I check x equal 2, okay, x equal 2, what will be the derivative now?
It'll be positive.
Positive 4. And yes, we said the gradient increasing, increasing, increasing. So this derivative, guys, this derivative, okay, this thing, is another function that basically plots you the gradient of the original function. I'll stop here for questions. So, just through some questions, I realized, you know, why is this so important? Why is it so good to get this derivative? Like, if I ask you, what is the derivative, okay, the derivative of this function when x equal 10, okay? Now, last lesson, you would have to do something like that. You'll say, okay, 10 plus h squared plus 1 minus 10 squared plus 1 and divided by h. That's how we calculate the gradient at a specific point. Okay? Every time, then I ask you, let's say, what is the gradient of x equal 100? Then you'll have to put 100 here. And that's complicated. But what we found out now, that I've got a function that tells you the derivative anywhere you want. You specify the x, it gives you the derivative. So if you want to know what's the derivative when x is equal to 10, what will be the derivative? 2 times 10, 20. If I ask you what's the derivative when x equal 100, 2 times 100, 100. So you have to do the legwork once. That was a long one. But once you've got the derivative, that's it. All you got to do is give me an x, and if I give you x, you can tell me what the derivative of that x. Okay? Let's do another example. Okay, so second example. Okay, we've got another function, g of x, this time minus x squared plus 3x minus 2. They didn't ask me, but you know, it's nice to be able to envision it. What kind of graph is this? It is a parabola, because it has an x squared. Unhappy face. Now, I'm not going to even draw the Cartesian, I'm just going to draw an unhappy face. I just don't know where it crosses the x and the y, it doesn't matter. Okay? So, they asked me to calculate using first principle. What we're doing now is first principles. Meaning, in a couple lesson time, I'll show you a much easier way, but it's not first principle. Okay? So, I've asked to calculate the g prime x. I'll do it in blue. Okay? So, g prime of x, I'm just using this formula. Okay? So, but instead of f, it's g this time. Okay? I'll start with the easy one. Okay? This is a bit more complicated because I've got 3 terms. G of x is, so I'll write it again. Okay. It's going to be gx plus h minus g of x divided by h in the limit h approaches 0. Okay? All I did is just instead of f, I'll call it g. Okay, let's start straight away with that. Oli, that's the one you found difficult. What do I do? How do I write? I sub x plus h. So what should I write? This is my function. Sub x plus h. So tell me. I'll read. All right. Minus.
X squared.
Is it x squared? No. What do you sub instead of x? X plus h. So x plus h squared plus 3 times.
3 times.
3 times x plus h. You can help all you guys. It doesn't have to be just him. Minus 2.
Minus
Okay.
the x plus h is like the should
Okay? Minus. That's this minus. What should I write now? In brackets. Anyone can help here, guys. Go on.
Oh, really?
Minus x squared. I like, Taylor, that you didn't forget that minus there. Minus x squared plus 3x minus 2. Okay? Because, you know, g of x, well, that's g of x. Okay, I'll pause here. I want to make sure you 100% understand. You're right. H over h. Okay? And I must always remind myself that h is flipping small. Okay? Alright, now, yeah, it's messy. I need to start opening it. Okay? So I'm going to put a minus there. I'm going to write x squared plus 2hx plus h squared. Okay, not cube, square. Plus 3x plus 3h. I know it's a little bit messy. Minus 2. And then I'm just flipping everything here because I've got minus. So plus x squared minus 3x plus 2. You got to do that very carefully. Okay, and I'll write limit of h approaches 0. So far so good?
Yeah.
Okay, opening. Minus x squared, whoops, minus 2hx minus h squared plus 3x plus 3h minus 2 plus x squared minus 3x plus 2 divided by h. And the limit h approaches 0. Okay, red pen. That's not red pen, that's fine. Red pen, that's the fun bit. Minus x squared plus x. Minus 2 plus 2. Minus 3x plus 3x. Anything else? That's it. As a rule of thumb, and in our rule of thumb, you must always have terms that have at least one h in them. You have to have some h in them so then you can cross cancel the h at the bottom. Remember, our aim is to get rid of the h at the bottom because he's really so small. So if you had like minus 3x, you didn't cross cancel it, then something went wrong. Everything must have an h. It has an h, has an h, has an h. Okay? Otherwise we won't be, if it doesn't have an h, then you can't cross cancel it. So I'm going to rewrite it again and take the factor out. Okay? So I'm going to write, I'll take an h out and I'm going to minus 2x minus h plus 3 divided by h. You happy with that? As I wrote them, I took an h out.
Yeah.
Okay, cross cancel the h. I'm getting limit, h approaches 0. And I've got minus 2x minus h plus 3. Now, after I got rid of the h in the denominator, yes, I can just substitute the h. I'm safe to put an h very small. So I'm getting negative x plus 3. And I will rewrite it down up at the top here. Okay? If g of x is this function, the derivative is minus 2x plus a3. That's my answer, right? That's my answer. I'll just pause for some questions. Right, so there's a couple more questions follow on this one, which will demonstrate the power of finding the derivative of a function. I've got a function and its derivative. Okay? Listen to this. They're asking us, determine the gradient of the tangent to g at x equal minus 2. Okay? So unfortunately I erased this parabola. Let's draw this parabola again. The parabola was a sad face. Eugene told us. Okay? So they said, look, at x equal minus 2, okay? X equal minus 2, I think it's somewhere here. Okay? This is x equal minus 2. There is a tangent. Okay? You know what a tangent, I think we played with them in analytical. It's this straight line. Okay? And they're asking for the gradient of that tangent. Well, the gradient of the tangent is basically the gradient of this curve. Okay? Do you get that? Okay? So the tangent is the point that kisses the curve. So the gradient of this tangent is basically the gradient of this curve. So they're asking us, what is the gradient of this curve when x equal to 2? What is the gradient? So what do you reckon I should do?
Substitute.
So in where?
In the
In g or g prime? We're finding the gradient. Correct, because g prime is the derivative. That tells you the derivative. So all I'm going to do, okay, I'm going to put g and I'll substitute x equal 2. So I'm going to put minus 2 times 2 plus 3, and I'm getting minus 1, isn't it? No, hang on, x equal 2 or x equal minus 2? Sorry, x equal minus 2.
7.
Okay? And you're right, the answer is 7. Okay? So you see how powerful this thing. Send it any x that you want, and it can give you the gradient. Okay? So the gradient is 7. That's the answer. Are we happy with that? Yeah. Right. The next follow-up is, at which value of x is the gradient of the tangent of g equal to minus 3? So in other words, they tell us that the gradient of tangent is minus 3, and they want to know what is the x equal to. So what is minus 3? Where do I put minus 3 now?
You say minus 3 equals.
Minus 3 equal what?
Equals minus 2x plus.
Very good. Okay? You see where the confusion will be here. You know how to sub, and you know how to sub y or sub by x, you know. But you've got two functions now. Whenever they're asking you about gradient of a function, that's the formula, it's the prime. Okay, so they told you the gradient is minus 3, please find me the x. And I'm going to see, what is that? 2x equals 6, so x equal to 3.
Yes.
Okay, so if they're asking us when is the gradient minus 3, there's a specific tangent here where the gradient is minus 3, please, what is the x? And we found out the x is equal to 3. That's obviously terrible because I drew a smiley face where it was supposed to be a sad face, isn't it? That's why I stuffed it up, but never mind, you get the point. Okay, I'm going to pause here, let's do some work. Bye-bye.